Hello and welcome to the self-audit for the ORB. I'm the developer Yoshiko, and in this video I'm going to be stepping through the code, every single function, just to explain it and basically reveal everything that there is to this code in order to prove that it's rug proof and it's not a scam and there's no exploits and none of that good stuff. So I want to prove that the code is good, and I think this is the best way to do that. If you want to follow along with me, you can go and look in the description and you should see a link to BSC scan or Etherscan. And when you click that link, it's going to take you to something like this. Now, this is my code on RinkB Etherscan, but the real thing will be on BSC scan. I'm just using this code because right now I'm in a test net. And I don't plan to make any modifications whatsoever, period, to the code. This is like the final version. And so, but yeah, in the description, look for a BSC scan link, and that will be the deployed contract. And you can follow along by just going here and copying the source code to the clipboard and then pasting it into your IDE or whatever tool you use, Sublime Text, Notepad, whatever, right? One thing I will say is that I'm not going to be providing a GitHub link. The reason why is because if you look at GitHub, there's no way to know if that's actually what's on chain. So you need to look for the code on chain in specific, even the helper functions. The orb.sol is the main contract, and these are my helper functions, right? And you can trust me and say, oh, well, these are coming directly from the source. Like safemath.sol is actually from OpenZeppelin. Well, I wouldn't trust me because, who knows? I might really be trying to go after funds in a malicious way. So you should go to OpenZeppelin, find their safe math library, and compare it to yourself. But we're going to be walking through the helper functions anyways. And it's not just OpenZeppelin code. It's like, PancakeSwap, for example, their factory and their router, all kinds of stuff. These are just standard helper functions. So with that out of the way, let's jump back into my IDE, and I use VS Code, and we're just going to start going through the imports. Well, I say imports, but before that, Pragma Solidity is just basically telling me it's my compiler version of Solidity. I'm sure you guys know that if you're following along, but it doesn't really mean too much. It's just the version of my Solidity compiler. So safemath.sol, we'll jump over into this. And this is a library taken pretty much directly from OpenZeppelin. It has a triad function in which it adds two uints together. There's nothing in here that's really too strange, right? It literally just takes two uints and adds them together and just basically tries to add them and then returns true and returns the result, right? Okay, and try sub, same thing. It does some subtraction math. All right, and then try multiply. It does a multiplication function. It also does a check for like some division. I mean, this is all OpenZeppelin stuff. I didn't write any of this code, but this is just basic stuff, right? Nothing malicious in there. Try div. It does a division. Try modulo does a modulo operation, as you can see. And then in the add function, it tries to do an addition. Sub, it tries to do a subtraction. Multiplication does a multiplication. Div does a division. Modulo does a modulo. Sub does subtraction. And div does a div. If you're wondering why there's different functions and there's overrides and stuff, some of them contain error messages, right? So like the difference between this modulo and the modulo down here is that you can actually pass in error message in case something happens, right? But so the last function we left off of was div. It just tries to do a division. And then there's the modulo. And that's just what it does, right? And in safemath.sol, as this isn't my library, you can actually read the big descriptions. I didn't try to edit it or anything. I don't think I edited this at all except for the Solidity version. So I'm just going to hit X out of that. And up next is context.sol. And what context.sol does is effectively it allows me to use a function that will return the message.sender of any sort of any caller. So when someone tries to do a transaction, I can get the message.sender using this message.sender function. Same as the message.data. I can see what data was sent with that. So again, this is just relating to the contract itself and I guess the transaction. And then it returns up the message data, as you can see. The msg.data and the msg.sender is things built in with Solidity. So there really hasn't been any modification to this. And again, this comes directly from OpenZeppelin too, or it might even be older than OpenZeppelin. I just look at their contracts, right? Okay. Up next is the ibep20.sol, which is the interface. I took this from, I think, the BSC Genesis contract stuff on GitHub, which is just kind of like a template function. Basically, how you're supposed to do things. And you might see this as IERC20, not just IBEP20. But I'm just trying to keep the correct nomenclature because the project is on Binance Smart Chain. All right, and so as an interface, this kind of just defines my functions. They're not actually doing anything, they're just definitions, right? And I have a total supply, decimals, symbol, name, get owner. All of these don't have any functionality attached to them. I'm just defining what they are, right? And then for events, again, events don't do anything to the code. They don't modify state, but instead they tell the chain something happens. And if you have a program, you can actually read the events. And that's how you can find good information about, a smart contract. Whatever actions happened, you can just track their events. Okay, so that's the interface. And then for ownable, I do need the owner because of transferring liquid or LP functions. Although if I could get around it, I wouldn't have an ownable because it does kind of say, oh, well, why do you need to be an owner of a contract? What's going on, right? It's specifically for certain functions. It's not to like take control of anything. It's just, I do need that in order to operate the game. And we'll look at ownable.sol now. And again, this is just taken from OpenZeppelin 2. As you can see, I've got an address for the owner. I've got an event that I defined, which again can't change state. A constructor, it just sets the message.sender, it calls that and get the message sender, and then I set the owner to whoever called it, meaning whenever I create the contract, it's setting whoever deployed it as the owner, right? And it emits an event. So emit is connected to event if you didn't know, and that's how that can work. So again, it doesn't change state, it just tells the chain saying, hey, this happened, right? The function owner, it's just a view and it returns the owner itself. So anytime you see view in this, it means that it doesn't change anything. It just gives you information, right? And so for example, I'm kind of cutting in here trying to explain a little bit of the basics because maybe you don't know a whole lot about Solidity, right? If I go back over to Firefox and show you where my contract is, I can click this read contract button over here and I can go to, let's see, owner, right? So there it is. It's telling me who the owner is. And in our case, because of ownable.sol, the deployer is the owner. So that's me. And looking back at the code, hey, there it is. There's the owner function. It did exactly what we thought it was going to do, right? Modifiers, only owner. The modifiers in Solidity are things you can attach to a function which call them, and it inserts its code into this little underbar semicolon, right? So any function that I do that has only owner, he inserts this code to the top of it, or rather I'm inserting the code into here, and then that adds this require statement. Basically, all this require statement is doing is that on certain functions, I can only call them if I'm the owner, which is really important because that's how, rug pulls and scams do happen, is people attach like a transfer function, right? And then they set it to only be the owner, which causes that only transfers can be done by the owner, which can really screw up, everything. That's basically a scam, right? If you can buy, but you can't, transfer out, then hey, that's definitely a rug pull, right? All right, so there's nothing too odd there. With renounce ownership, I do have the ability to set my ownership to the dead address, which I would never do, but it is just a standard thing in the ownable contract. Transfer ownership, again, probably I wouldn't ever do this, but this does have the power to set a new owner and nothing else, as you can see. Okay, and moving on from ownable, let's go back into this, and now we have the pancake swap functions. Now, truth be told, I don't really know specifically how this works, right? I didn't write these contracts, but they're used by the contract itself. And so we'll just look at the interface for iPancake Factory, right? And again, the Solidity version up here, we have an event or a pair creation. Whenever an LP gets created, that happens and it emits the event. We have a fee too, which gives the fee. And like I said, these are all views, so I can't really do much, and I don't define them. So I'm assuming the LP pair itself will have the code in there to do it. So what I'm trying to say is I can't really add too much functionality, right? Because these functions are all views, right? There's fee to setter, get pair, all pair length. And then we actually have one that actually does do something, and that's the create pair. But again, I'm not actually adding any functionality. So this functionality would be done so by the pancake swap, whatever pair gets created itself, right? I don't have any control over that code. Same as the set fee to and set fee to setter. Now, I'm not entirely sure what this is, but this is actually new. This is actually in the version 2 for Pancake Swap, and I just decided to add that in there because, hey, that's what they're saying the interface should have. So again, it is a view. It doesn't have any functionality, and like I said, none of this stuff has functionality I defined in the interface. It just defines it. Okay, so moving on from Pancake Router, or to the interface Pancake Router 01. And again, there is a ton of code here that just, is just definitions. I don't actually assign any functionality to it at all. And some of these are pure, which is similar to a view. Basically, I can't modify any states, but it gives me the factory, gives me the WETH address. With Pancake Swap routers, I can add liquidity, add liquidity ETH. This is all standard functionality for a Pancake Swap router. And this is all normal stuff. With permit is something that they have added in there. You can check Pancake Swap itself to prove that I'm not changing anything or doing anything out of the ordinary. Same as the swap tokens and the swap exact ETH for tokens. These are just functions that Pancake Swap has normally. Get amounts out and the quote, same thing. That's all Pancake Swap stuff, and I'm not defining any functionality at all. All right, so moving on to Pancake Router number 2. As you can see that this calls Pancake Router number 1, which we already went through. And again, this is just, this is just definitions of functions. I'm not adding, as you can see, I'm not adding any functionality at all to the definitions. It's just an interface, and all of this is just standard Pancake Swap stuff. That's it. Yeah, swap tokens for ETH. There's nothing going on. All right, so now that we've done all of our import stuff, now we can actually get into the ORB contract itself. All right, so starting at the top here, I'm just setting the name as the ORB. I also make it context, and I also make it IBEP20 and ownable, so it's inheriting these imports into it itself. I'm also using safe math for uint256, meaning I get access to all those functions in the safe math import that I just showed you. So then I define a Pancake Swap router variable, which will contain the Pancake Swap router itself. I have a pair variable, which will contain the address. You see address, contains the address of the variable, and then also the router address for the DEX, meaning I need an address for the Pancake Swap router to actually create the router. I also have 2 strings, which are name of token, symbol of token. I've got a uint8, which is the decimal of the token itself. I've also got uint256, which is the total supply of the token. Nothing really out of the ordinary there. I've got token balance, which is a mapping. Basically, that controls how much token everybody has on chain. The allowances of the token is how much other people are allowed to spend of someone else's, right? This is a standard approval, a standard allowance type of thing. Amount of orb stake, that's my mapping where I track how much orb each address is staked. I also have two bulls here to track if they've staked or unstaked orb. I've also got a timer. Basically, I'm tracking the time that each address has staked. And then I created a dead address variable. I don't know why this isn't standard, but I just feel like it should be something there that you can define. Oh, and by the way, if you're wondering why I'm not setting any values up here, it's because if you have a proxy, you can't really do this. You have to like set them in the initializable. So I prefer never to set the values up here, and instead I set the values down in like my constructor, but we'll get there. So that's just an explanation why I don't set any values up here. Just a preference. I'm not saying it's wrong or right or whatever. Now for next, I've got a bool is all staking unlocked. This is for basically 5 days after staking starts. I will call a function that unlocks everything, and people can withdraw their orb if they want, but at that point in time, it's pretty much over, right? The game is done, effectively, is when I would call that and cause that. I've got a creation date of the contract. Oh, I see a problem here, that little C, but I'm not going to change it because this will all be version 2 stuff, and it's, you know, I'm trying to keep this as a finalized version. It doesn't really matter that there's the mistypoed C there. It just, you know, that's in the variable, right? Do I even use this? Oh, wait, yeah, I do. I do use that variable. I was about to say, do I even use the creation date? But yeah, I do. Okay. Then the pre-sale rate, this is just the rate of, you know, in the pre-sale, it's 1 BNB to 1,000 orb. So that's just a variable that helps me set that. For is pre-sale enabled, that's just a standard checker to make sure that the pre-sale is actually on. For mapping, I have a basically a tracker to keep up with how much orb an address has purchased. So right now I'm limiting the number of orb someone can buy to 1,000, effectively spending 1 BNB. And so they can't, basically it just tracks it. And the reason why I'm having to track it is because if I just got the balance of in their wallet, what they could do is they could buy 1,000 orb and then send that 1,000 orb to somewhere else, and then they could just rebuy. So I need to track the amount of orb being purchased by each individual address. Okay, and so for the uint public, well, oh, and by the way, public is just saying that, you know, you can look at it on the in Etherscan, right, or BSC scan. It just means you can actually directly look at the variable itself. It's not saying that someone else can change that. I know that some people get a misimpression of that, but it's not what that means. It just means you can see it up here. Now, if I set it to private, you wouldn't be able to see it, but for the most part, most of my variables up here are public, except for these ones, which are just standard. All right, so continuing on, I think we left off, we talked about the orb amount purchased in pre-sale in Jaeger. And Jaeger, by the way, is the smallest amount of BNB, as opposed to Wei. I don't know exactly how to pronounce that. So this is the time pre-sale ended and liquidity provided. So after the pre-sale ends, I move the liquidity to PancakeSwap, and this is the time of it. So it keeps track of when I actually did that, and it has to be uint 256 because we use the Unix epoch time or something like that. Is that what it's called? Hold on, I'll check. Yeah, basically it's a Unix timestamp. Epoch time is something else. You can look it up on Wikipedia if you want to read some. That's not really relevant, but yeah, those are Unix timestamps. Same thing for time staking is enabled. I record that timestamp when staking goes live. I have is approve enabled, and this is very important because in the contract itself at the start, I disable approvals for a good reason. The reason why is because I don't want someone to take the orb and create their own liquidity in PancakeSwap during the pre-sale. So I have to make sure that approvals are turned off until the pre-sale ends. This isn't a rug pull type of thing. This isn't me trying to stop people. You can still transfer your functions. You just can't allow other people to spend your orb, which is how Uniswap and DEXs and stuff like that works. So this is the bool for that. And later on, we'll look at that code in detail and just show you how that works. I also have 3 variables here to keep up for timers. It's a 1 day, 3 day, and a 5 day timer where I set a Unix timestamp to represent 1 day, 3 day, or 5 days in uint256 as a number. So, all right, these are my events here. And again, like I said earlier, events don't really change the state or anything. They don't matter. They're just events I have for information, right? There's a pre-sale purchase, all staking unlocked, contract deployed, minted orb, orb staked, orb unstaked, in pre-sale provided liquidity. And I do need some of these events because I want to be able to see who was the first one who staked and who was the first one who unstaked, and I give you awards for doing that during the game. Okay, and we've made it to the constructor. Here's where I define the dead address to actually be the legit dead address. I get the address from the message sender or the deployer, right? Remember we talked about context.sol. So now I've got the message to sender, or message sender. I set the name of the token to be the orb, set the symbol, I set the decimals to be 9, I set the total supply of the token to be 1 million because it has 9 decimals. To get us past there, I do, 10 exponential 9, and then 10 exponential 6 gets us to 1 million. I then set the token balance of address this to total supply of the token, which means I'm setting the contract address to have that token balance. I'm not giving the deployer or the owner the tokens. I'm instead giving the contract itself the token balance. I then emit a transfer event just saying, hey, this is what, the transfer took place. I then emit an ownership transfer as well, moving from the dead address to, the deployer. The router address for the DEX, I'm setting this as Uniswap's address for right now because I'm testing on Rinkeby. But when it goes live, I'm going to uncomment this line, which will be for the version 2 PancakeSwap router. I then create the router address, or the router variable, so to speak, using the interface for the Pancake router. And again, I don't really define any of that functionality. All of that is coming from PancakeSwap. I then create a PancakeSwap pair using the iPancake factory, which you can see like this gets its factory. This variable here gets the factory for PancakeSwap. And then I do a .create pair, which it creates a pair of the token's address, which refers to the contract, right? The token, the orb's address is address this because it's referring back to the contract. And then I also get the WETH address, which even though this is on BSC, they still call it WETH instead of like BNB or whatever. I'm not sure exactly why they didn't change the name, but they don't. So I'm not changing it here either. And there we go. I get a PancakeSwap pair. And I also set this local variable into the global variable. So I'm not entirely sure why I did that. I'm sure I could save a few lines, maybe save a line or two, but I'm not trying to change it right now. So I just set that into a global variable there. I then set a variable for 10,000 tokens, which is just, 10,000 times 10 exponential 9 in order to get past the decimals. I also do 30,000 tokens, right? And then I set a variable which subtracts from the distribution. And so I subtract the token balance in the contract address, the 30,000 tokens basically. So basically that's taking contract tokens and giving them to the team. And like I said in the overview video, we effectively get 3% of the total supply, which is really low in comparison to a lot of other projects. But that's just kind of handling the deployment costs, the marketing costs, the NFT costs, the, anything project oriented. That's why we're getting 30,000 tokens. So also I set, or basically I'm giving it here. I'm setting the token balance of these 3 addresses, which is me, Nox, and Is or Yis. I'm not entirely sure how to pronounce it. I think it's Isu, but not too sure. And these are the developers, and yeah, I give us each 10,000 tokens. I then say, is all staking unlocked? I set that to false because all staking is not unlocked. I then set the creation date of the contract to the block.timestamp, which just records the current block's timestamp. I'm not sure what else to say about that. Solidity has some cool features where you can just say 1 days and it knows that it's 1 day. You can also do like 10 minutes and 20 minutes and stuff like that. So I set the 1 day timer, 3 day timer, 5 day timer as 1 day, 3 day, 5 day. All right. And so you might see my comments too. You see the change it's here. That's mainly just because, hey, you might need to change some code. I love these tags. If you're trying to learn how to code and stuff, definitely use change it, fix it, to do's, any sort of thing that will help you, remember what you need to change in the code. And I've already changed it to be the correct times. We'll use that later. I'll show you in the code later on where we actually use the 1 day, 3 day, 5 day timer. All right, so is presale enabled? Yes, it is, because right when the contract is live, that is when the presale starts. The presale rate is set to 1,000, which means 1 orb equals, or 1 BNB is equivalent to 1,000 orb. I set is improved enabled to false because remember, I need to stop the approvals while the presale is going on so no one tries and maliciously creates pancake swap liquidity while my presale is going on. All right, and it emits an event called contract deployed, the orb launched. So that is the constructor. All right, so after the constructor, we've got a name, which is a view. And again, views can't really do anything. They can just tell you information in Etherscan or BSC scan. Name just returns the name of the token. Symbol returns symbol. Decimals returns the decimals. Total supply tells you the total supply. Balance of. If you give it an account address, it will tell you what the balance of that account is. Get owner will again give us the owner. Transfer. Okay, so this is actually a real function of what happens when someone sends orb to another person. Transfer internal gets called. What happens in transfer eternal? It checks to see if it's transferring from the 0 address or to the 0 address. If it is, it won't let it do it. And it does check to make sure the transfer amount is not 0, so it does need to actually be greater than 0. It then subtracts the amount of token being sent from the sender and basically updates the sender's token balance. It then adds the amount to the recipient's token balance and sets that as the new token balance. And it emits a transfer event. Then we have a transfer from, which basically allows you to transfer from one address to another, provided that the approvals have been done. So it does a transfer internal, a function that we just went over, and approve internal. This is a little bit different, but it's effectively right below it, and we can just look down here and see what it's doing. I do use the is approve enabled, meaning that it has to only happen after the presale ends. And later on in the code, it shows you where it flips that to true. It also makes sure that it's not going to or from the 0 address. And then it sets the allowances of the token of the owner and the spender to a certain amount. So when you do a transfer from, he checks to see if the approvals have been set up before the transfer occurs. Basically, it's just saying that someone else can't spend your tokens unless you allow them to, unless you approve them in order to spend their tokens. So that's what that does. And kind of this is all standard functionality except for the is improve enabled. All of this stuff is, normally found in most every smart contract. Oh, and then at the end of it, it does an emit. Oh, and also I just want to say the return trues here are just, telling the transactions, hey, it worked, right? You're returning true and saying, yep, it transferred all right. So then approve is just a way to get into approve internal, but it allows someone to interact with it through Etherscan or through dApps or anything else. It allows a user to approve someone else to spend their tokens. All right, and so now we go down to the allowance functions. This allowance, similar to approve, but it's allowing someone to spend a certain amount of tokens, and you can set that. And this is all basic stuff or standard stuff. Increase allowance does exactly what it says. It increases the allowance allowed of spending. Decrease allowance, same thing. It makes sense. You're decreasing an amount allowed to spend, except you can't decrease it below 0. And you'll notice that it does approve internal. So you actually need to approve that this is, happening, so to speak. And that's how that works. Again, this is all standard stuff, not changing anything about it. All right, so minting, this is a standard mint function, is that when this is called, and it's important to note that this is not a public function. This is an internal one. So I can only call minting internally. I can't call it from Etherscan or outside of the world other than this contract. I can only call it from within this contract. And so then it just does a check to make sure I'm not minting to the 0 address, because that would be kind of dumb. It adds the amount to the total supply, and it adds the amount to the person who called the mint function itself. So the account that is minting gets its amount added to its tokens balance. And then it does a transfer event, just saying a transfer occurred. And I also added in a minted orb event of my own, which is kind of pointless, but I mean, I did want to see, hey, this actually happened. Okay, and so that was the minting function. I'm going to skip the staking functions for now. We're going to come back to it because it would make more sense to tackle the pre-sale functions first. And so we're down here, and this is the pre-sale buy. I require is pre-sale enabled, which is set to true when a contract is deployed. So that's the first requirement. I also require a key code to be 1337, simply because I don't want someone who doesn't know what they're doing to use this function, right? So I only want it to be done through my website. It just keeps people, I guess, safe. I don't know. It's just a safety mechanism. I don't have to have this, and you don't either if you're trying to make your own contracts. I just kind of like to have passwords for dApps because sometimes users will try to go around something, right? And this just helps it. Of course, this doesn't really help it, because if someone knows what they're doing, they're just going to look at your code and find the password anyways. This isn't a true password function. It just helps idiot proof it, right? All right, it sets the buyer to message.sender, so whoever calls this function is the buyer. We also check the amount they sent, because this is a payable function, meaning you actually have to put in a certain amount of Ether or BNB in order for it to work. This gets the amount of BNB entered. I set this as being the amount in Jaeger for 1 BNB. I then do a division saying, okay, BNB must be at least 0.01 BNB, because that's the minimum amount they can use, or they can spend in the pre-sale. It has to be over 0.01 BNB. You can change it to be whatever you want. And then I also set to make sure that it's not over 1 BNB, right? So I'm making sure that no one's trying to give 10 BNB. The maximum is 1 BNB. Then I do some math to add the amount of BNB that was actually input into this function. I add it to a mapping, which basically tracks how much pre-sale orb someone has bought. Yeah, that sounds right. How much pre-sale orb someone has bought. That's how it's tracked. And then I set this to the amount purchased with new purchase. This is just a tracking. And then I do a requirement saying, hey, if you've bought over 1 BNB, you need to input less BNB. So, and I tell them how to check their current purchase amount. Because say someone buys 300 orb and they're like, well, how much did I spend in the pre-sale, right? And they might not remember, and I don't know how they would, but that's just something I put in there in the requirement. But yeah, they can't buy over 1 BNB. I then do some math to determine how much orb someone gets. I do a multiplication of the pre-sale rate, which is 1,000, and then I do a division of the 1 BNB in Jaeger, which gives me the amount of orb that I need to give them. I then get the total balance of the contract, because remember, our orb for this pre-sale is in the contract itself. I then subtract the amount of orb in the contract from the amount of orb to give. Or how does that say? How do I say that? I subtract the amount of orb to give from the total balance in the contract itself. And later on, we're going to update that, right? The total balance after give, I set a new variable for that. I also set the amount orb minimum for LP creation, because After the pre-sale, I want a minimum amount of 100,000 orb. The reason why is because if I don't set this, I could end up in a situation where the pre-sale sells out and then I don't have any orb to supply the liquidity, which would be kind of funny, right? I doubt that'll happen, but I just want to make sure I don't get into that situation. So I have 100,000 orb minimum, and then I do a check just to require that to make sure that our orb amount in the contract never goes below 100,000. Then I set the amount purchased or amount purchased with new purchase to how much someone has purchased in the pre-sale with that mapping. That updates that there. I then do a simple multiplication of 10 exponential 9, which gets us past the decimals, and that's the amount here. And then I subtract the token balance from the contract address where the orb is stored. I subtract the amount from the token balance, and I update that token balance there. I also add that amount to the token balance of the buyer here. I then emit a transfer event, and I emit a pre-sale purchase event. And that steps through the pre-sale logic. I think that this logic can be used in other projects. So if you're watching this video trying to figure out how stuff works, there it is. Nothing malicious, nothing crazy. That's just how a pre-sale function can work with the contract itself. I came up with that, or at least I'm sure someone else has in the past, but I came up with that on my own. So now we'll do in pre-sale provide liquidity function. This is the function that I call, and remember, it's an only owner function, so only the deployer or the owner can call this function. And what it will do is it will end the presale and move the liquidity into PancakeSwap automatically. This makes it where the owner never has to touch the liquidity. He never has access to the LP. All right, and so from here, it's a requirement of saying I cannot end the presale yet because it has not been 1 day. That's right. So creation date of the contract is set in the constructor, and then the 1 day timer is 1 day of time. So I force myself to only be able to call this at minimum 1 day must pass before I can move the liquidity and end the presale. This is a good thing because it forces me to keep to the presale date. I think it's also a good thing to have something like this because you could end up making a mistake where like you end the presale too early. Maybe you don't exactly know what you're doing, and this kind of helps idiot proof it. Then I get a new uint 256. I get the amount of orb in the contract. I also get the BNB in the contract by doing address this dot balance, and then I do the balance of for that. Pretty standard stuff, right? I then set is approve enabled to true, which allows everyone, not just myself, to approve and set allowances. And basically it just means you can now create liquidity pools in any DEX, not just PancakeSwap, but I'm setting this to true. And the reason why I have to do it here, like I've explained before, is because if I don't, then someone can maliciously create liquidity in PancakeSwap without me knowing or without anyone else concerned, and he can ruin the whole thing. Because then you're having such a small amount of liquidity, it's very hard to adjust that past the initial liquidity provision. So that's why I do that there. But after this called, I approve enabled, and then everybody can do allowances and approvals and all that good stuff. And that's automatic. Like I said, that's automatic. There is nothing else I can do to change that. It just happens automatically when I call this function. I then do an approve eternal, which we've already went over. Effectively, I approve a PancakeSwap router to spend, so to speak, or I approve, not so to speak, but I approve the amount of orb in the contract to be spent by the PancakeSwap router's address. I then do add liquidity ETH, which is how PancakeSwap and Uniswap stuff like that works. I add the BNB in the contract paired with the amount of orb in the contract. And then I set the owner of the LP to the contract. So I don't send the LP to myself or anyone else on the orb team. Instead, I send the LP into the contract itself. I, again, don't have any access to that liquidity. That's all the contracts. And I don't have access to withdraw it from the contract itself too. And keep in mind that if you do have a function that allows you to withdraw from the contract, This doesn't mean it's rug proof, because that means that the creator can just get the LP out of the contract. But in this contract, I don't have anything like that in there. So next, I do a time presale ended and liquidity provided. I set that variable to the current block timestamp. I then set a variable called time staking is enabled, which I add 1 day to this variable, right? So I'm saying that 1 day from now, 1 day from the time this function is called, that's when staking is enabled automatically, which allows people to stake after this timer expires. So I don't control when people can stake, it just happens automatically. I also set is presale enabled to false, which turns off the presale, because after it's done, it's done. No one else can get in. I then emit an event, and that's it for that. At the end of here, I do set the contract itself to be payable, so someone can send me Ether or BNB. And at the bottom there, I just have a bunch of comments. By the way, if you're not used to this, if you see the purple or whatever and you see these things, these are comments, so they're not real code. It's just dev notes I put in. And now we're done with the staking function, or sorry, not the staking, but we're done with the pre-sale function. Now we're going to go back up to the staking functions and go through that. Okay, and so this is the stake orb function, and it takes the amount of orb you need to stake on the website. The time staking is enabled cannot equal 0, which is set when the pre-sale is ended. And then I also make sure that the block timestamp is greater than the time staking is enabled, basically saying, hey, it needs to happen now, because remember, back in the other function, I set a 1 day timer. So 1 day has to expire past the pre-sale in order for staking to happen, because it goes to PancakeSwap first. So there will be 1 day of presale, although it doesn't have to be 1 day. I plan for it to be 1 day of presale and then 1 day of PancakeSwap liquidity, and then staking can happen. Go back up here. And that's that requirement there. We also require is all staking unlocked to not be enabled. It needs to be false, because if all staking is unlocked, then I don't want anyone to be able to stake after that. The staker address, I just do a message.sender to get whoever is staking. I also check to make sure he hasn't staked before using the has staked orb mapping. I check to make sure that he has at least 1 orb to stake. I also make sure that he isn't going over the maximum of 1,000 orb. I then check to make sure that he has enough orb in his account to actually do that. I'm not even sure if I need this requirement, but I put it in here because I was like, okay, I need to make sure he does have enough in his balance before he tries to do that, right? Because otherwise I think you can get into a weird logic situation where you can do that. So I just do a requirement, make sure he has enough in orb in his account to stake. I then set has staked orb to true, because if this is his first time staking, I just set it true. I then set the amount of orb he has staked to that mapping. I then do I subtract the amount of orb staked from the staker's balance. I add that amount staked to the debt address. This isn't really a burn, because the staker is going to get it back anyways. I just store his staked amount in the debt address temporarily. I then make the time started staking the block.timestamp, because I need to keep track with this, because in 3 days he's going to be able to unstake. And then I emit an orb staked event, and that's the stake orb function. So next is the unstake orb function, and here I just do a message sender to get the staker address. I check to make sure he hasn't already unstaked, because I don't think he can possibly get into that situation. I just want to make sure that he's only unstaking once. I then do, I set has unstaked orb variable to true, so he can't re-enter it. I then check to make sure that is all staking unlocked. If this is false, basically I'm saying I have a new requirement saying you can't unstake, it has not been 3 days. So that has the 3-day timer. But if all staking is unlocked, then I ignore this requirement, meaning anyone can stake after all staking has been unlocked, which is, I think, 3 days after, or no, sorry, 5 days after the staking has started. Okay, and then I do a subtraction amount from the dead address to subtract the staked amount. And then I add that staked amount back into the staker's address, which returns how much ever he staked back to his address. I then do a minting feature, which I check to see how much orb the staker has generated so far, and we'll explain that function later, but I get a certain amount to mint, and then I mint that amount to the staker. So there's 1 million APY, and that's, basically dependent about how much he inputted in. I think the multiplier is about 8,000 something, and I mint that to it. And so then I set the amount orb staked back to 0, and I emit an event saying, hey, he unstaked the orb. And so far, I just want to point out that there's been nothing where like I can transfer things to my wallet, I can't rug pull anybody. There's been no malicious, like, overt functionality. So just want to make that clear that although I'm going line by line, you can see that there's not anything that I'm doing specifically that would, cause a scam or cause a rug pull or anything like that. So up next, we have stake unlock time, which is a view. All it does is it's getting the unlock time for a staker, which again, this is all set when someone goes and stakes, but it determines, you can see here the time started staking plus the 3 days timer. So that's telling me when the unlock can happen for a user. And I also do a if statement up here to say that if it's equivalent to 0, the time started staking, meaning he hasn't started staking, then I just return 0 up here saying, okay, if he hasn't started staking yet, then his unlock time is going to be 0 anyways. But he can never get to here unless he's staking. Just putting that out there. Then time until staking unlocks. Again, it's a view, so no state changing or anything like that. It takes a staker address. It checks to see if it's equivalent to 0. Again, similar to up here. It basically returns 3 days if the user hasn't started staking yet, because we're saying, okay, he hasn't started staking, but it'll be 3 days until he starts. And then we check to make sure that the block.timestamp is greater than, or we don't make sure, but we're doing if check just to say, okay, is his timer plus 3 days less than the current block timestamp? Because if it is, then we're returning 0 saying, hey, he can unstake. So does that make sense? If the current block timestamp is greater than the time started staking plus his 3 days of a time, then that means it's done. So he has finished his staking and can be unlocked. So that's how that happens. I then call a function called stake unlock time, which is right above it, and we've already explained that. I subtract the current block.timestamp, and then I get the actual time staking unlocks for the address. So this is how I'm counting down. This is the countdown timer, so to speak. But that only occurs if I haven't returned 3 days or if I haven't returned 0 ahead of time. So then after that, we have unlock staking, which is again an only owner function. This is only a function called by the deployer. I require that staking has been enabled first. I also require this 5 days have elapsed after staking. So this is a requirement against the owner, so he can't mess anything up. Of course, you don't necessarily have to have it, but it's really important to, because what if someone, starts the staking process and the owner tries to rug pull by unlocking staking early and he unlocks his own orb without telling anyone, right? So this is kind of the requirement. Although you can do the 3 days, this is just kind of is a way to end the game. The reason why I have that in there is because after 5 days, the liquidity for orb is going to be gone. Like all the BNB, all the prizes and stuff is just gone. So I decided to just put this in here and say, okay, well, if the staking is already done, everybody's out, just unlock it for everybody and let them get their orb out if they want it. The orb is probably going to be worthless, but who knows, right? So I just give people the option to unstake earlier. And I also is all staking unlocked. I set that to true because remember there are other functions that check that function, right? Like staking and stuff. I also emit an event. And then this function is staking ready after sales. This is mainly for checking to make sure that that the pre-sale has already ended and it's saying, okay, is it ready? This is mainly used on the website just to make sure things are going, and I can prove that, right? We'll do that. Yeah, this is just a view. This doesn't actually change anything in the contract. This mainly helps dApps keep up with, hey, is staking ready or whatever usage on the website. So again, that doesn't change anything. It just returns false if staking isn't ready and returns true if it is. Timestamp of current block. Again, this is just a helper function. I don't think I use this anywhere except, yeah, this is just helper for dApps just to say, hey, what time is it exactly right now? I do how much orb after staking 3 days. This is an estimator tool. Again, this is, I think, yeah, well, I actually use it down in how much orb has been generated so far. So that's not necessarily true, but yeah, this is how I'm calculating the 1,000,000% APY. And so I determine amount orb generated by doing a multiplication of the amount of orb staked by calculate 3-day rate. And so if I do that, I can show you where that function is down here. I call calculate APY, which is another function. It's basically math, right? This is just mathematical formula of how to calculate APY. There's nothing too crazy going on there. I don't call any other functions. I just do some division, addition, multiplication, and subtraction. I return. There's probably a better way to do this, by the way. So if you're looking at this, this may not be the ideal way, but that's just the way I figured out for me. So, but after all that, I do calculate of APY, get 3-day rate. I return this back up to where we were. So now I have a rate to multiply the amount of orb staked with, and then I return the amount of orb generated. So you can actually view how much orb you're going to get back by staking. I then, there's this other function here, the how much orb has been generated so far. This is called when someone goes to unstake. And so when someone goes to unstake, this is called, and this is a view returns, right? And he gets how much orb was staked by the staker address. So you can see the amount of orb staked mapping here. I'm passing in an address, and that will check how much orb someone should get when this is called during unstaking. I know that's a mouthful, but still, that's how I determine how much orb gets generated. I then have a new variable called time unlock. I get the stake unlock timer for this person's address. I then make sure that the current timestamp is greater than the time unlocked, because if the timestamp is greater, then I just return the total amount generated. If it's not, however, because remember, I can unlock things early, I do some other multiplication and addition down here, which determines how much orb is generated from someone unstaking, after the 5-day time, right? If they choose to do so. So, and again, there's no other sort of transfer functions. There's just no malicious function that I've added in here to try and trick people or anything like that. It's just math right here, and then I return the amount of orb generated. All right. And so that ends the staking functions, and we went over the APY functions, we went over the pre-sale functions, and I think that is it. So we're just gonna, start from the top and make sure I've explained everything. I went through the imports, went through the variable declarations up here, went through the events, went through the constructor and all the code inside of it, setting all those variables. So all of those are basic things. Get owner. I go through the transfer functions and talk about transfer internal and what happens there. I go through the approve functions and point out about the is approved enabled requirement that I've added in to stop, people maliciously adding liquidity. I then go through the allowance functions, which again, they also have to do approve internal when you increase and decrease the allowances. I talked about the mint function and how that works. I went through the staking function, so stake orb has been gone through. unstake orb has been gone through, stake unlock time, times until staking unlocks, unlock all staking, is staking ready after sales, all of this, right? These are just views and stuff I've already talked about. How much orbs after staking, how much orb has been generated so far, so just talked about that. These are the APY functions when I calculate APY and calculate 3-day rate. I then talked about the presale and how that presale function works, and then I talked about the end presale provide liquidity, where I end the presale and I provide the liquidity to PancakeSwap. Already talked about that. And I have the receive external payable, which makes the contract payable, or it makes the contract able to receive BNB and ETH and stuff like that. So, and that's it. And there's no other hidden functions or anything like that. And that's the self audit. So yeah, I don't know what else more to talk about. I think that this provides me personally an audit that says I can't be exploited. Someone can't hack the contract. I can't rug pull anyone. And, if someone says that, no, they're wrong, they're going to rug pull you, it's a scam, well, just send them this video, right? Where I go through every single line of code. And I can talk to anyone about it, right? I know this code front and back. I can answer anything. I can answer why things are occurring. I don't think I'm going to be getting audits from anyone. This isn't against them, but audits don't seem to be very... I don't mean to sound rude, but I feel like a lot of auditors are just taking advantage of the fact that nobody knows what they're doing. As crazy as this sound, a lot of audits don't catch exploits, from what I've noticed. A lot of audits are incorrect a lot of times. And so I think that this audit is a much better way to prove to customers and prove to myself that, hey, this audit is, or this code is clean, right? It's not a rug proof. It's not a scam. And like I said, if you have any questions, or if you want to, talk about the code, or maybe claim that it is exploitable, let me know in the Discord, and I can hook you up with some BNB if you find an exploit. I don't mind. Although we don't have a true bug finder program or anything like that. I mean, I would be impressed if you found a bug within the contract and could exploit it. And if you don't exploit it and you tell me first and we fix it, then I can reward you in BNB, right? So, all right. Well, that's a wrap up. Thanks for watching. Bye-bye.